Section 4, Qualia, an explanation from physics, ? No one, Gray says, has yet proposed any kind of theory as to how the non-system biological properties of the constituent cells of the brain, their biophysics or biochemistry, might give rise to qualia. Consequently, most neuroscientists have stuck to functionalism and accepted that qualia are the inevitable result of certain types of behavioral or cognitive function. But Gray concludes that if we do undermine functionalism, as Gray does, then, quote, we have ruled out cybernetics as a possible route by which to reduce consciousness to the existing corpus of biological principles. A move, you should be warned, that is in flagrant defiance of mainstream contemporary science and philosophy. That leaves the laws of physics as the only alternative, end quote. Having arrived at quantum physics as the only probable domain left in which we might be able to find an explanation as to how qualia originate in the brain, Gray turns to the most developed theory of this type, that of Roger Penrose and Stuart Hamerhoff. Gray and others have taken to referring to their theory as Penhoff. Their basic thesis is that consciousness arises from the orchestrated objective reduction of quantum superpositions. The word orchestration in this phrase refers to a process through which, according to Penhoff, connective proteins associated with microtubules influence or orchestrate the quantum reduction state. This speculative idea is based on Penrose's particular interpretation of quantum mechanics. They posit that these reductions occur within the microtubules of neurons. Microtubules are part of the structure of all cells, but according to Penhoff, in neurons, their tiny inner spaces provide the shelter from high temperature and other disturbances necessary for quantum coherence to take place. As Gray puts it, Penhoff claims that, quote, the system of microtubules in neurons is the only one in the natural world likely to provide conditions for objective reduction of quantum superpositions. In this way, the theory manages neatly to find proto-consciousness in the very fabric of space-time, while yet limiting full-blown qualia to just those systems, brains, where we know them to be housed, end quote. In other words, Penhoff claims that proto-conscious qualia are embedded as quantum superpositions in the fundamental geometry of space-time at the Planck scale. When a superposition of quantum states self-collapses, i.e. objectively collapses, into just one of many possible states, that particular state becomes fully conscious. The other states into which the quantum function did not collapse had the capacity to become conscious, but they did not. They were proto-conscious. Gray comments that, consequently, quote, we should find proto-conscious qualia wherever there are quantum superpositions. It turns out, however, that this prospect is a lot less panpsychic than it seems. Proto-consciousness may be everywhere you look, but not consciousness itself. Penhoff stipulates that only quantum superpositions which remain isolated long enough to reach threshold for objective reduction are conscious. This is a fairly stringent requirement, met only in the brain and perhaps nowhere else, end quote. And why should this be the case? Quote, because you need a superposition large enough to reach threshold in a reasonably short time to avoid decoherence. An isolated electron in superposition wouldn't reach threshold for 10 million years, end quote. But, as Gray points out, a large superposition is difficult to isolate. Providing a solution to this difficulty is the ingenious part of the Penhoff theory. It postulates that large superpositions are protected inside the protein structures of microtubules, such that they reach the threshold of collapse in a time short enough to preserve quantum coherence. As Gray explains, quote, proteins are fairly large mass-wise compared to electrons, and have the unique property of having their mechanical conformational state sensitive to quantum level events like the location of electrons. So they are the levers or amplifiers. They are large enough to exert action in our macroscopic physical world, but small enough to be in superposition and sensitive to quantum level events, end quote. In other words, the protein in microtubules acts as a converter, turning quantum states which contain protoqualia into truly conscious qualia, which can be experienced at the macro level. Gray goes on to ask, what advantage then, if any, does the theory derive from having linked protoqualia to the fundamental fabric of space-time, end quote. The answer, I believe, is that it links consciousness not to local evolutionary complexity, but to the fundamental physics of the universe. One of Gray's major criticisms of the quantum mechanical model of qualia generation is that it fails to explain how the different types of qualia, shape, color, sound, smell, taste, touch, etc., are produced. The theory proposes that qualia enter into consciousness when a quantum wave function collapses. It then postulates that a reduction in a given region gives rise to the corresponding type of qualia. But, as Gray points out, there's no reason within the quantum mechanical model to link a given type of qualia with a given region. Quote, the model gives an account of the event, orchestrated objective reduction of the wave function, that causes something or other to enter consciousness, but not of what, end quote. The explanation of what kind of qualia is, as Gray says, quote, smuggled into the model by way of knowledge stolen from elsewhere, end quote. By this reference to stolen knowledge, Gray is pointing to the already well-established correlation between certain kinds of qualia and certain areas of the brain. For example, area V4 gives rise to the experience of color. But Penhoff's quantum explanation fails to identify any mechanism which could account for this fact. As Gray puts it, quote, "All we do have is a series of brute correlations between, on the one hand, activity in this or that part of the brain, and on the other, the occurrence of this or that kind of qualia," end quote. Given this, it seems to be the case that this quantum mechanical correlation with qualia merely shadows the other two kinds of non-explanatory correlation that we've already established, i.e. that between qualia and functions and that between qualia and neurophysiology. For example, the correlation between color qualia and the area V4 of the brain. Gray complains that all we end up with is the idea that qualia has three sets of non-explanatory relationships with respectively functions, neurophysiology, and quantum mechanics. As Gray insists, quote, "The presence of a systematic relationship on its own is no more than a brute correlation. To advance to the status of a scientific theory, one needs an account of just why the systematic relationship takes the form that it does. No one has yet achieved this for the brute correlations of either function or neurophysiology with qualia, whether these are considered separately or jointly. Is there any reason to think that a brute correlation between quantum mechanical processes and qualia would fare any better?" End quote.